In this module, I'm very excited to be introducing you to a whole new application that involves a camera module. Specifically, we'll be talking about person detection, or sometimes referred to as the visual wake words application. As I've done with the keyword spotting application, I'll be talking about the overall application architecture. So let's get started off by talking about what this application is all about. Person detection is really simple. We want to know if there's a person in the camera viewpoint or not. For example, you're seeing a person of interest here, and on the right-hand side, you're not seeing him. So if there's a person, we want to be able to notify, yes, there's a person. If there's no person, I simply want to be notified that there's no person. This simple task has many diverse applications in the real world. For example, if you're deploying this sort of person detection in office buildings, you can use this to automatically turn off the lights or turn on the lights depending on occupancy. And that could be quite useful for conserving energy, especially in office buildings that are large and consume significant amounts of energy, electricity. So let's get started in understanding, what's actually involved in putting, such an application together. There are two components as usual. There's the initialization phase, and then there's the steady state main loop. The steady state main loop has got multiple components involving the pre-processing, the inference, and the post-processing. Hopefully by this point, you're quite comfortable with what those terms mean, and I'll still step through them in some detail. So let's get started in the initialization phase. The initialization phase has got two subcomponents. You've got to initialize the camera, and then you've got to set things up for your model. So by and large, this breaks down into smaller steps that can be covered into a lot of detail, as we did in the keyword spotting application example. So basically declaring all the variables all the way to setting up the main loop, which is going to execute repeatedly. The first step is to initialize the camera, which is as simple as making this one single function call, camera.begin. And as you can see here, the function call takes a couple of arguments. The first argument, QCIF, is what's called a quarter common intermediate format. And that's a standard that means something in terms of resolution. The second argument is grayscale. In order to do person detection, you don't need a colored image. So we simply need a grayscale image that consumes less number of pixels and takes up less space. The third argument is the number of frames per second. How often do we want the data to be coming in from the camera? And the final argument is just the specific camera module itself, which in our case is the OV7675. Then we move on to allocating the model in the initialization phase, which involves declaring the variable, setting up your interpreter, tying up the interpreter input to where the buffer that is associated with the camera module. So the camera dumps the data into a buffer, and that buffer has then got to get passed into TensorFlow Lite Micro, because that's where the neural network is, going to be seeding its inputs along. And then you set things up in the main loop. So that's pretty straightforward. Let's get into the pre-processing part. The pre-processing stage involves two components, which is reading the image and then cropping and converting that image. So reading the image simply involves invoking the function call that gets a frame of data from the OV7675. The data that you get back is in this format that I mentioned earlier, the QCIF. QCIF has a precise resolution that's associated with it, which is 176 in the number of columns and 144 in terms of the number of rows. This data, with this function call will then end up on your embedded system. The next part, before we actually go into the inference stage, is really cropping and converting the model from QCIF into the format that's rendered for our actual neural network. In this case, it's all about scaling the original QCIF image into a 96 by 96 square pixel. And this can be easily done through this little function that we've already provided for you. You're cropping the image down to size, and then you're converting it into a format that's ready for the neural network to consume. Given that, once we have the input data that's ready, we simply invoke the model. In our case, the model that we are invoking here is a mobile nets model that actually runs on top of the image to detect whether there's a person there or not. And in order to invoke that model, this is all we do. At this point, you've got to be quite comfortable with actually looking at this API and knowing exactly what's happening over here. And then the next step is figuring out what needs to happen during the post-processing phase. Remember, the post-processing phase is all about understanding what to do with the data that has come out of the neural network. So in our application, it's all about responding to whether there's a person detected or not, which is simply going to go through the LEDs that are present on our embedded system. So for this example, if there's a person in the view, we simply want to light up the green LED. And if there's no person in the view, we simply want to light up the red LED. And that's all there is to it. So hopefully, one of the key things that you're seeing now is that compared to keyword spotting, the visual wake words application for person detection is remarkably simple. So not every application has the same level of complexity in terms of initialization, pre-processing, inference, and especially in post-processing. So just keep that in mind. One of the things you should also think about is the fact that the stages tend to stay the same. So there's a certain pattern that repeats in terms of how you want to process this. And if you want to look at something that you want to change, then you can keep that in mind. So just as I said, in the same context of the keyword spotting application is that, we can actually get a little bit more creative now in terms of how we actually deploy an interesting application using the camera module, which incorporates person detection. But in addition, we'll incorporate, other sensors, which make it much more exciting. And so more on that soon.